using Docker for multi-platform development, and basically I want to talk about the two big problems that I use Docker as a tool to solve for myself, and some of the things that I kind of learned along the way. This is a very opinionated talk, but this is how I use it. Is absolutely not how you may want to use it. The idea being that this is kind of a case study of workflow that I use. It's by no means a best practice or something that I would judge you for doing differently, but hopefully you'll be able to take away a snippet here or there that you may be able to apply to your own workflow. So. Now it's not playing nice. Okay, there we go. So problem number one, I do a lot of development work from multiple machines. So right now I use 3 different machines. Two of those machines are Windows 10 and one is Ubuntu. And one of those machines belongs to somebody that I contract for, and so sometimes it gets replaced or different fun things that I get to deal with that. So getting a consistent development environment across all 3 of those can be a big challenge. Until recently, Windows is really lousy for web stack support and those types of things. So running a web server was always a chore on Windows. And so that was kind of problem number one for me, was running a work environment across 3 different machines. The other big problem that I have is over the last few years, between different employment options and contract jobs and startups that I've worked at, I've worked on a ton of different platforms. I was tallying it up recently, and I think just in the last year to 18 months, I've written code that runs on Drupal 7, Drupal 8, WordPress, Craft, Zencart, Shopify, Magento 1.9, Magento 2.1 or 2.0, I can't remember, Joomla, Moodle, and I'm sure there's about 8 others that I've forgotten at this point. And every one of those platforms has a different set of requirements. Some of them run great on PHP 7, some 7.1. Some of them will not run at all on 7, and you have to go back to 5.3. There's all kinds of different requirements for every one of those platforms. And so managing all those requirements in a consistent way where that environment is consistent between other developers and between like a production environment it can be a pretty big challenge. So those are my two big problems, and basically I've used Docker to solve those problems for myself. So what is Docker? Docker is one of the more popular container systems. There are other container systems out there. Basically a container is a platform that shares the host operating system in a slightly different way, usually more efficiently. At the kernel level, instead of a virtual machine where it's taking up an entire stack of resources, most of those resources are shared in a container. You might compare it to a sandbox, like how your browser sandboxes different tabs, so if it crashes, only one of 2 of those tabs crash, as opposed to the entire application. Containers also typically are isolated network stacks, so unless you define a network, they don't have a great way to talk to anything without some definition there. They also tend to be disposable, so they're designed to just be how many do you want, delete them when you're done, that kind of stuff, whereas a virtual machine tends to not be something that once you build the virtual machine, it's a pain to delete it because it's allocated all this hard drive space and things like that. So I don't want to get too deep into the nuts and bolts of Docker and how it works for this particular talk. I really want to spend more of the effort on showing you guys like how I use it as a tool. So version control is one of the other big things for me as I was looking at ways to better accomplish these various tasks. I'm a self-taught programmer, and so early in my career, working for myself, I tended to be the only developer on a project, and version control was not a thing that I even cared about. But as I've grown up, if you will, and I work on teams and larger groups and bigger projects, version control has become super important for me. You've all probably edited a file over FTP. We've all done it, and we've all crashed a site, I'm sure. But generally, version control is a direction that we want to go as we get bigger, better projects. And it's the only way, really, to collaborate in an open source community. It's just too hard to keep track of who's changing what and who's working on what without something like that. So version control is a big part of how I solve problem number one, which is working on different machines. So I'm always committing code, and then I can just pull it down on any machine that I want to work on. But Docker config becomes consistent because I can also commit that config to version control. So I can take it to this machine, I can take it to that machine, and I can replicate that environment that I had on the other machine pretty trivially, and I can keep that in version control. And so that really helps me solve that problem number one of working on multiple machines. Indirectly, that solves the problem of having multiple developers and everybody needing different dependencies. Because I installed the GD extension for PHP years ago, and I forgot that I installed it. And now, people are trying to figure out why my code won't run on their machine, and silly thing like that. So Docker forces you to be a little bit more explicit and say, hey, I need these. This stuff needs to be on this box. And so everybody gets a consistent development experience. So because it's containerized, going back to versions, you can run whichever version of PHP. You can run multiple versions, one on each container. Well, you can run them on the same container, but I don't know why you would do that. And so each of those containers having a different set of extensions that they require, extra apps maybe that they operate with, and all that stuff. I can keep all those versions inside my Docker file, and then I can version control it and kind of keep those things consistent within the project. And I can also more easily match a production environment than it used to be possible. If you're installing something like MAMP or WAMP or just a typical LAMP stack, who knows what other dependencies you might have installed along the way that you have on your machine that aren't in a production environment. And a lot of your big hosting providers have specifications. Some of them even have Docker images where you can run basically an identical copy of their production environment, which is super cool for making sure that that weird custom thing that you wrote works everywhere instead of, well, it just works on my machine. What's wrong with yours? So really quick, some reasons that Docker is not for you. Maybe you hate the command line. Maybe you already have a really solid development workflow and you're pretty happy with that. That's probably not a great reason to jump to Docker. And you might also have some needs for physical hardware. So Docker doesn't play as well, although I recently used a Docker image to control a Raspberry Pi, so that was pretty cool. But there tends to be a lot more difficulties if you want to talk to a USB device or things like that. So physical hardware tends to be where I'd be like, Docker's not a great fit for that. So let's jump into a quick tour of some of the tools in the Docker project, and then apply those tools to a project. So Docker Community Edition is what most people are going to end up using. They have an Enterprise Edition. I'm not really familiar with it because it's pretty new, but I think that's part of their plan to actually make money, which is, thing that we all have to do. So Docker Community Edition is actually completely open source now through the Moby stuff. And so the Community Edition is the installer that you need to run on your machine or a server. So they have packages for all the major Linux distros, and then we have Docker for Mac and Docker for Windows that run on those. And so Docker for Mac and Docker for Windows actually install a virtual machine because you need a Linux kernel to play with Docker. And so what's cool about that is they've worked really hard to abstract that virtual machine away. And so you don't even actually realize that that's kind of what's going on under the hood, because all the commands are the same whether I'm on a Linux box or a Mac box or a Windows box. Every command is identical, and the results in the environment are always consistent. And so it's actually hard to tell if you don't know. If you just put somebody in front of a command line, they wouldn't notice the difference. They're typing in Docker commands. Inside of the Docker project, we have a command called Docker run, And so run is a command. If I just want a Ubuntu box, I can type in docker run and Ubuntu, and it'll run a Ubuntu instance. There's some caveats with that because that command is not going to actually do anything. It's going to boot up a machine that completes instantly. Because the Docker container needs to have a process always running inside of it, or it stops. It's like, well, you're not doing anything, so here, I have a stopped container. So most processes inside of a Docker are going to run in the foreground. So Docker run lets me start up any kind of image. You can start up, I believe there's an official Drupal image, and I can just pull that image from the repository and start it right up and have it running on my machine in just a couple of minutes. So that's the Docker run command. The Docker file allows you to start taking that one step further and customizing that. So I can build off of someone else's image. So I can take the official Drupal image, or I could take the Ubuntu image, and now I can start defining, okay, I'd like to also have this service available, or I'd like these PHP extensions to be installed, and those sorts of things. Docker Compose is a super cool piece after that. So Compose basically is a definition of a set of services. So multiple containers all in one file. So now I can say, give me a database server and a web server and a cache server if I would like. So which leads us to the stack that we're going to talk about here for purposes of this talk. Which is basically it's an abstracted stack, but it's pretty close to what I use every day for the projects that I work on. So that stack includes nginx as a web server, PHP FPM as the PHP backend, and MariaDB as the database, and Mailhog and PHP MyAdmin as sort of those admin dev tools that are handy. It looks something like this. All the incoming traffic goes through nginx, and then I use some rules that we'll talk about later to actually take that traffic and split it up if I need to go to one of the other instances inside the containers ecosystem there. This is kind of what I use for like a basic structure of a project. Typically, most of the projects that I work on right now don't like me to put my Docker files in the project, and so I usually keep those separate one layer below the actual code I'm working on. And so it might look something like this, where I've got the config files, and then inside the repo folder I'm actually using Git or Mercurial to track the application code. So in this example you can see the Kent folder, which is a cool project that I use to do some different debugging. If you use the Xdebug, that is something that I have not been very successful at getting running in Docker, and so that's something that you can get done, but is a little more difficult. So I tend to use Kent as a variable dumping tool. It's pretty cool. So this is the Docker Compose file, part of it, that I use. And so this is the definition for the nginx instance. And so that instance is defined as having an image. So the image that I'm using is the nginx Alpine image. Alpine is just a really lightweight Linux distro. If you're not doing a lot of customization, it's super cool because instead of 200 megabytes, it's like 5 megabytes. So transmitting that image over the wire in a build process or something like that is a lot faster. So then I've defined some links on the nginx instance, and in this particular scenario, I'm talking to my PHP FPM backend, and I'm talking to the PHP MyAdmin box, the Mailhog box, and for some reason I have the database on there. Normally don't need the database on the web server. So then I've defined some volumes. So the way that Docker mounts files into the file system is through volumes. And so I've mounted, in this particular case, 2 different files or folders into the system. And so the first of those is a specific nginx config for this server. And so that nginx config says, hey, nginx, bind on this port and all that stuff. And I'll go through the nginx config file here shortly. And then I've told it I want you to mount the files folder for this fake Drupal site that we're working with here. Everything else is going to be passed to that PHP backend, and we'll go through that later. So the only thing that is actually living inside the nginx instance is the files directory, so that can serve those static files really quickly for us. So this is the next service in the Docker Compose file here. This is the PHP FPM instance. And so we're using the FPM is a little bit faster. My preference is FPM. There are other options. You certainly could do an Apache PHP stack all in one container. But typically the mantra with Docker is one service per container, one running application per container. Because generally what you're doing is forcing yourself to build a system that will scale really well. So if I put my web server and my database on the same container, I've now limited my ability to scale. And so abstracting those out, forcing myself to do it early on, allows me to build a system that's a little bit easier to scale out. And now I need 3 database servers for some reason. It's a lot easier to do that because I don't have to code it out as 3 different boxes because I've already done it at the front. So same kind of definition here. We're actually building a custom Docker file in this particular case. So we've told Docker where to find the Docker file that we want to build from. And then we've told it again which other services to link to. And then we've told it which files we want to mount to the instance. And so we can see the Kent repo for debugging, the php.ini that I'm using, and of course the application source is loaded. And then because I'm using custom settings for this particular Drupal project, I put my own settings PHP outside of the repo, and then I'm mounting it into the appropriate place on the Docker container. So the database definition is here, and so we're using the MariaDB image. And then we've told it a couple of things that image has handy are environment variables that tell it what we want to do as it boots up. So if you're using Docker Hub to find images that typically document things like this, you can also build your own images that use environment variables loaded into the system in different ways. In this particular case, we've defined a root password, and we've told it, hey, I want you to start up with a database already created so I don't have to mess with that, and use the name of database name. And then something interesting with volumes is the named volume. In this particular case, I'm mounting a volume for persistence. Once I've loaded the database on there, I don't want to load it every time I spin up this Docker container. So I've said, hey, take this db volume name and just store this varlib MySQL folder on that volume. And so that causes that data to persist. If you stop a Docker container, the container basically pauses. And you can start that container again, and it boots up just like a regular machine kind of would. However, if you take that container down, you tear the container down, you destroy it. And so all the files that were on the system that were not in volumes go away, which is great because now you don't have to mess with cleaning up all that stuff. But not so great if you didn't mount the database folder outside of that container because it'll be gone. It also allows me to transfer things between systems a little bit easier. For example, I could mount that for rlib MySQL folder to a folder on my machine, and then I could zip that up and move it to another machine and unzip it and boot this container up, and I would get the exact same database, which would be pretty cool. In this case, I've commented out the port definition. The port definition allows me to connect that port directly to the host machine. So basically I've said, hey, allow the Docker instance to open port 3306 on my local machine so that I could access it with Workbench or something like that. I've commented out, but this is how you would basically open those ports up to the external world. So the link command allows me to connect containers to containers. The port command is then, okay, now I want to be able to connect to the web server. So open port 80 for me. Maybe I want to use SSL, open up 443 for me. So here's the definition for the mailhog instance. It's the simplest and shortest definition in this Docker Compose file. It says, hey, go get the mailhog image and call it mailhog, and that's it. The host name definition basically overrides. When you're using a Docker Compose file, it does some auto-generated naming for you, particularly if you have multiple services that you boot up. with the same name. So maybe I have web server 1 and web server 2 because I'm emulating a load balanced environment. And so I would have those in there. This basically I'm saying do not use mailhog_1. Use the name of mailhog so that later in my config I can reference that directly. Here's the PHP FPM instance, or sorry, my admin instance, which is just handy. This happens to be what I prefer to use. Workbench is not my friend, and so I use PHP my admin. And it also means I don't have to mess with getting inside of the database container, mounting it directly to the system or anything like that. And they've got some environment variables that allow me to set that up pretty easily. So that was the Docker compose file that I typically use as something along those lines. And here we're looking at the nginx. Thank you. My preview screen is smaller over here. So this is the nginx config file. And this is just a snippet of what I generally do. Basically, I've set it to send file off because of performance issues with Docker. So that's a little tip that took me a long time to find because the way Docker mounts the file volumes over the network is weird. And so telling nginx to use the send file off command actually performs a lot faster. So then I've said, hey, allow me to upload giant files because maybe I'm putting a MySQL database dump through PHP my admin. And then some cool things that I did here. Of course, I've mounted the app root to the nginx server so that it can grab all those files. And then I've mapped anything that's /PMA to actually inside of that definition. It passes it to the PHP my admin instance. So I don't have to mess with port numbers, which is typically something I would have to do if I had 3 different web services running on here. So basically just told nginx, hey, when I type /PMA, ignore the PHP FPM instance and go to the PHP my admin. Same thing with mailhog. Mailhog opens up on like port 8025 by default. And basically I've told nginx, again, if I type in /mailhog, just take me to the mailhog interface. And then what I've also done that's really cool for some projects is maybe I've got a client that's got gigabytes of images. Nobody in here has those kinds of clients, right? And you're like, I don't want to replicate the entire environment, but I need to replicate this bug. And so I don't want to download all those images. And so now you're working on a site with all these broken images, and it takes forever to load because it's getting 404s. What I've done is I've taken a folder, in this particular case, the sites all folder, and I said, hey, load all the files. If you don't find the file on your local mount, then proxy that to the actual production server. So pass the request on to the production server so that we can take advantage of all those resources being out there. As long as I'm connected to the internet now, I can actually see those images in place without having to download all gigabytes and gigabytes of them, which is super handy. So this is a little bit of the actual PHP backend. So basically we've told nginx, hey, these are the PHP files and this is how to handle them. So try doing these different things to it, and then basically it sends that to the PHP FPM instance on port 9000. So inside of the Docker ecosystem, you'll reference everything by the names that you assigned it, like in the Docker compose file. So I don't have to put in IP addresses or anything like that. When Docker boots up, it messes with the /etc host file and puts these definitions in for you. So all I have to do is tell nginx, hey, you're connected to it, now use this backend. And so here's the actual Docker file. So this is the nuts and bolts of the PHP FPM instance that I use for a lot of different projects, with some variations, of course. So basically, this is documented on the official PHP image as to how to use the tools to build specific PHP extensions. What's cool is they don't use any pre-built binaries. If you just sat down in a Ubuntu box and typed in sudo apt-get install PHP 7, you get a precompiled binary. So the Docker instance that it actually runs through a full build, and then it caches that. So it's the recommended way to actually use PHP is to actually compile from source, and so that's actually what it does. So I've specified from PHP 7 FPM for this particular container, and then I want to do some things after. So if you went online, you could find the official PHP 7 instance, and you can see how they built that. What build tools did they use? What scripts did they run in there? What things did they add to it or subtract from it? All that good stuff. And so then I've taken that particular box as a starting point and said, okay, cool. I want to use the libjpeg and libping because I need GD support on here. A weird thing is I need Golang on here because the mailhog send mail binary is actually written in Go. So we're actually going to compile that later on. I don't think I have that screen on here. So what's cool that's not in this slide is a new feature that Docker recently introduced, which is called multi-stage builds. And so basically, instead of doing all this funky stuff that we're doing here, which you'll see a lot in older Docker files, I can take a binary and compile that binary in a box and then copy that binary from the build box into the next box in the stack without all of the caches and things that it downloaded. So for example, you get a really large image size if you put the make commands and the GCC libraries and all that stuff to compile from source. So generally you want to remove those things when you ship that image around, particularly going into production. You don't want to send a gigabyte image over the wire if you don't have to. So you want to take some of that stuff out. So the multi-stage builds actually takes all of this stuff that I'm doing here to build the send mail binary for Mailhog, and I could just build it in one container, copy it out of that container into the next container, and then of course that would be cached in the build process later on. But I wouldn't need to remove the apt files, all the stuff that it apt downloads, because that would just stay in that other container that we basically throw away after that. So then we, using the Docker PHP ext configure script, which is documented in the official PHP image there, and telling it to install the different stuff. And then we're installing the sendmail binary for Mailhog. So basically telling everything on this box that I want you to use Mailhog instead of trying to send mail through typical server channels or any other options. Because I don't want to send spam to all my clients or anything like that. But I do often need to see what those emails are generating. If they're generating at all, those types of things, super awesome tool. So here's the PHP INI file. Really short and simple and sweet. All the defaults are good for me in this particular case. One thing that I like to do is use that Kent library, and so I've pre-appended the Kent library at the beginning of everything that runs on the site, which is nice because now I'm not keeping it in my repo, and I'm also able to use that without storing it in a folder and having to ignore it and all those kinds of things. So as soon as I push this into a QA environment, that's not available to me anymore, but I don't have any trouble with that lingering stuff that can happen. So then we're just telling it, hey, the 2 megabyte minimum that's in the defaults there is not enough for us. We need a little bit more. And then we're telling it, hey, use the sendmail binary that we configured before anytime you want to use sendmail. So we're at the end. If this sounds pretty cool, but maybe it's a little bit too technical, I would highly recommend check out the Calabox project. It's fairly PHP generic. It runs pretty decently with WordPress. It runs great with Drupal. And so that basically is a interface that makes Docker a little bit more user-friendly, a little bit easier for you to use. And if you're not interested in getting into the guts of those files, Calabox is a great way to get some of the advantages of Dockerizing your project without actually having to do too much of the Docker type stuff. The Acquia Dev Desktop is a virtual machine, I believe, and it is not Docker, but it's a great way to abstract your work so that you're getting consistent results as well through that. So if you're interested in more, Matt Glauman, good friend of mine, has a couple of projects that he uses to use Docker on his particular stuff. And so the Commerce project template has I think it's a docker compose.yml.dist file that he's got a full definition that is a super great starting point for building your own Docker stack for Drupal. Not necessarily specific to commerce, but could definitely work with either one. And then he's got a command line tool that's super awesome for sort of scaffolding some Drupal-specific stuff, making the process of doing things like drush, which is something that I did not cover, a little bit easier. So basically kind of mapping those commands using that tool. So that's a pretty cool tool if you're interested in going a little bit further. So in summary, I hope you saw how I solved my two big problems working across multiple machines and operating systems, and how easy Docker makes it to run different versions and different dependencies and different things like that, and how to add in some cool development tools like Mailhog without completely foobarring your production environment. So with that, I'll take what questions we have. Yes, sir.
Question, where are your files actually stored then?
Yeah, so the question is, where are the files stored? So if we go back, all the way back, here's a folder. So I tend to build my stuff in like C:/projects. And so then the name of the client or the project, and then underneath that, I've got a structure that looks like something like this. So then when I go in here and I tell it volume, what's on the left side of the colon there is where the file lives in my local system. So the / is a relative link. So inside the Docker Compose file, I use / to say wherever Docker Compose file lives, use this as the root for mounting that file. So in this particular case, you saw the Docker config folder, and that's what I'm mounting different files out of into the Docker file system. More questions?
Any problems with, I've heard recommendations that you really shouldn't run SQL as a Docker object, because when they shut down, sometimes it can be not very nice for SQL. Is it just because you're using it for dev that you don't get those problems?
Yeah, I don't think it's a big problem in a dev environment. So the question was, are there any issues with using MySQL in a container because of the way that containers can shut down? For development, definitely not. I've never experienced anything as an issue with corrupted data or anything like that. For production, there's definitely some concerns there. The odds are you're not going to be turning that off and on a lot more. And then the other thing is you absolutely should be prepared to handle what happens if that container completely fails, right? What happens if my data center loses power is a legitimate question, and how do you handle that failure? So you should be planning for that regardless of whether or not the container is the best environment. And that's something that production, you're going to have to make your own decisions about whether or not that's good. But I run it in production, and I'm super happy with it and never have any problems with it. So limited experience window, though.
So you do use this. This is not just for setting up dev environments and emulate production. You can actually use this for production too.
Absolutely. So like Pantheon is a variation of this. They run containers. Platform.sh has their own container technology that they use. Now, Docker has actually open sourced what they call the Moby project. So you could actually go take their source code and build your own spin-off from their source code that's your own type of container. So this is underpinning this is a technology called LXC, if you want to dive a little bit deeper into it. But yeah, absolutely great in production as well as local stuff. There's obviously different concerns, but if you're using something like AWS, they've got some really great templates that'll just spin up containers for you.
I think the biggest Docker user in production right now is Netflix. Uses Docker. They like spin up like 1 million or something like that a day to do all the transcriptions and stuff.
Docker instances are super awesome for worker processes where you need something temporary, something short, something to do one thing. So basically you can treat it like an executable, and it can go do a task and then it can shut down. And so it scales really neat. And if you have access to a cloud like Amazon, how many do you want to run? 1,000, 10,000, 100,000? Cool. We can do that. So
the majority of Netflix is actually hosted on FreeBSD servers, and they're using jails, which is a similar concept but predates Docker.
I thought DrupalCon guy that did Docker presentation was talking about that.
yes.
my questions. I've been working with Docker now for the past 6 months. I've been downloading some of the Docker builds that are on the hub. And I'm at the point now where I've worked with a few of them and I like certain things of this one and that one. And I guess what you were talking about with the compose file, that's what I was going to do was just go straight to the Docker file and start to hack away.
Sure.
Is it required to use the compose file, or is it just recommended, or?
So the question is, where does Docker Compose fit into the ecosystem?
Yeah.
The answer is Docker Compose is a way for managing multiple services. So in this particular case, I have nginx and PHP FPM and database, right? And I want to run them as 3 separate containers. Now, I could use the Docker run command to boot up each image individually, and then I can link each of those images and run all of that stuff. But the Docker Compose allows me to say, hey, every time that I want to start this instance, start it with these files mounted, as opposed to having to do Docker run -v and specify a volume. And so, especially in this case, I'm running 3 containers at a minimum. And you can run 1 container out of a stack. If it's linked, it'll automatically start anything that's linked to it. But I can start up just the nginx server, and then it'll spin up the PHP FPM server, which will spin up the database server because they're all connected. But you can create, for example, a temporary worker box that you use for some particular task. And so you can use Docker Compose up and then the name of the specific box that you want to bring up, and it'll bring up any dependencies that it needs. But you don't have to necessarily run everything that's in a Docker Compose all at the same time.
Okay. That's like some of the issues I run with is like trying to run 2 Dockers at once, because I'm doing that with the Docker run, but I'm setting a port like 8080 and constantly
Sure.
trying to run 2 Dockers at the same time. You got to keep changing the port numbers.
Right. So that's probably a more advanced type of thing. What you would run into, I typically just turn off one project and turn on the other project and move on about my day. It keeps me a little bit more consistent and frees up some resources. But when you're mapping to port 80, well, there's only one port 80.
Yep.
And so you're definitely going to run into that. There are some folks that have built, I believe there's an nginx image and an HA proxy image that basically interface with Docker. So you would run those inside of a compose environment, but basically you'd run those outside, and they listen for an environment variable that you can set in those boxes. And that environment variable is, hey, my domain name locally is whatever. And so then that box basically proxies port 80 to whatever container has that name. And so I can run multiples through that. I find that to be a little bit slow, but that could just be my system because it's basically doing 3 stages instead of 2. So nginx is talking to PHP FPM in my setup. In that setup, you'd have an nginx or an HA proxy in front of your other nginx and your stuff behind it there. So I found that layer to be a little slow for my taste, but to each their own. And you may find that there's somebody's built a faster one than what I last messed with. So, yes.
I'm trying to figure out the best way to get started. There's on Docker, it's called Docker Hub. I remember existing Drupal Docker repositories. Is that something you recommend downloading one of those to learn? Start from scratch and try to.
Yeah, so the question is, what's the best way to sort of get started with Docker? And the short answer is absolutely. Anything that's labeled an official image, I believe there's an official Drupal image. You can pull the source code for it, and you can take a look at how they built it, or you can just pull it in and make a couple modifications and start from that. And they usually have pretty decent documentation on those images. Those are all at hub.docker.com. And so you can search for like the PHP image, which has all the different documentation on how to do the various steps of that. What I also often do, this is the long answer, is I cheat and I go to GitHub and I search for specific things and then I set the filter to Dockerfile or docker-compose.yml and I go look at what other people have built and I'm like, oh, that's how they did it. So that's a secret tip for you. Any more questions? Yes.
For the use case of replicating a production environment on local, right? So how this is different from Vagrant? Docker is different from Vagrant in that use case? And is there one is better than the other for that?
Sure. So the question is kind of what's the difference between Docker and Vagrant? So as far as your local machine is concerned, Vagrant is basically spinning up an entire virtual machine. Now, in the case of Docker on Windows or Docker on Mac, it is also using an entire virtual machine. However, every container runs on the same virtual machine, whereas with Vagrant, if you're doing an actual stack, you would have 5 different virtual machines for the configuration that I showed running on there. Each of those allocating, hey, I need 2 gigs of RAM. Hey, I need this much disk space. I need all these things. And so you could end up with a lot less resources if you're doing that. Most Vagrant configs that I've seen are all the resources running on the same virtual machine, which then prohibits you from being able to scale out. So in this particular case, the exact configuration that you saw there with some minor changes for production is actually what I use in production. I obviously don't keep the PHP my admin instance running because I don't want that on the web. But I want it in my local stack. So I have some changes like that, but I actually run the exact same stack in production for a couple of different sites. Whereas at Vagrant, it'd be a lot more challenging to do that with. And it definitely wouldn't scale. So if I want to run 2 nginx instances because I'm getting high traffic and I want those on separate boxes, super easy to do because I've already been built and configured to do that. With Vagrant, I'd have to figure out how to break those services out of that particular virtual environment and then scale up from there. So it's no wrong answer or right answer to that particular question. There's just some differences. I don't think I've ever seen anybody use Vagrant in production. The same build commands for Vagrant, sure, absolutely. Definitely could do that, but I don't think I've ever seen anybody run that in production. So, more questions?
You described what happens on Mac and Windows. What happens on Ubuntu when you run Docker?
Because you have, so the question is, what's the difference? So I described to an extent how Mac and Windows work, but what's the difference if you're running Ubuntu as your desktop when you're using Docker? And so the big difference is